Dear students, good evening. I am Ramdas. I welcome you to my channel Maths from Basics for You. This is my class number 28. In the previous class, I have done that is part 2 of parametric equations or parametric functions. I hope you are well versed with it. So, I had told you some portion of parametric function was lagging. I have covered it up. So, if I want to have done more problems, let us not waste more time on that. So, I am going to switch over to successive differentiation part 2. In the previous part, that is part 1, we have learned some problems on successive differentiation, which is part of differentiation. So, dear students, today we will learn successive differentiation part 2. Here I will be covering up some important problems and it will be important for you, the examination point of view, and some difficult problems selected from textbooks, some various textbooks and from question papers. So, this will help you a lot in solving problems on successive differentiations. So, without wasting much of our time, let us start. But before that, I remind you of my funda, learn maths right from basics. I am here to teach you maths right from basics. So, dear students, I am putting sincere efforts, hard work to see that I educate you, I teach you mathematics. So, don't you think even you have to reciprocate in kind? So, as such, I request you to share, like and subscribe to my channel. So, with this note, I will start with this problem. If y equals log x by x, show that d square y by dx square equals to 2 log x minus 3 by x cube. So, this is a problem which is very important. So students who have just got into my class, that is who have missed out on my previous classes, I request you to please follow right from class 1 up till until now, because class 1 comprises of formulae which is very important for differentiation. Without building that a good foundation, you cannot get through differentiation and score good marks. So, formulae are very important. So, try to memorize it and keep it at your fingertips. That will help you a lot. Without formulae, you cannot proceed. So, here let us start with this problem. So, dear students, here the moment you see d square y by dx square, it means to say that it has to be differentiated twice. Okay. So, we have been given a function y equals log x by x, wherein you have to use quotient rule to solve this problem. So, let us differentiate once, that is given y equals log x by x. Now, differentiating with respect to x, we get what? Dy by dx of d by dx of log x by s. So, dear students, those are still in parametric functions. I wake them up and call them. See, we are going to differentiate this with respect to x and not with respect to theta or with respect to t. This is with differentiation with respect to x, because we find only x terms here. So, no parameter t here, we have straight away x, differentiate this with respect to x. So, forget parametric function for a while and concentrate here. So, we are going to differentiate this y with respect to x. What happens? We will take this, which implies, that is, okay, I will take the next line. So, this equals to what? Denominator square, I will write this denominator x square. So, here x into d by dx of log x minus log x into d by dx of x. So, I'll rub this. What happens here? Now dy by dx equals to, denominator I'll write little down, equals to x square, the denominator square. So x into d by dx or log x is 1 by x. So that becomes 1 by x minus log x, d by dx of x is 1. So 1. I'll rub this. So those who are not familiar with quotient rule, d by dx of u by v. So this is the form u by v. So what this is? Nothing but v square, v into d by dx of u minus u into d by dx of v. So this is a formula we are going to we have used here. So what happens here? X and x cancels. We are left with what? 1 minus log x divided by x square. So what is this? This is our dy by dx. I'll rub this. Now he wants d square y by dx square, means to say that you have to differentiate this once again. So what happens here? Differentiating again with respect to x, what happens? That is d by dx of dy by dx equals to d by dx of 1 minus log x by x square. So we are differentiating once again. For that we have to use d by dx of dy by dx equals to d by dx of this. So you can straight away, you can avoid this line, you can say d square y by dx square equals to, you can differentiate. But as a procedure you are supposed to do this, because I don't want you to lose even a single mark, because some examiners are strict. What they do is, when you try to avoid steps, they will not give you full marks. If you want to score full on full, you have to write all the steps, then only you get your full on full, otherwise no. Okay. Some students who have done very well, I will be scoring 100% 100 out of 100. When they get their answer sheets, I mean to say the marks cards, either they will be 98 or 97 or 99, because somewhere they would have lost one step, they would have lost that mark. So I don't want you to lose a single mark, because even decimals 99.97 will make lot of changes in your life. You may end up in getting a particular degree or particular seat, your engineering seat, in the place where you wish. You may get it somewhere. So to see that you select your proper seat in the college you wish and the place you wish, try to score full on full. So I am going to help you out for that, and please concentrate here. So dear students, I'll rub this. So you have to differentiate once again. Now here again you have to use quotient rule, because you have u by v. This is u and this is v. Done. So now d square y by dx square will be what? I write this x square the whole square. So this will be x square into d by dx of 1 minus log x minus 1 minus log x log x into d by dx of x square. So this is our quotient rule. Let's simplify this. This will be x square the whole square. So this will be x square. So once again this becomes what? Minus 1 by x minus 1 minus log x into d by dx of x square is 2x. So let's simplify this. This is a d square y by dx square. So d square y by dx square equals to, so this will be 1x cancels and becomes x times. So this becomes minus x minus 2x into 1 minus log x by x to the power of 4, because x square to the whole power of 2 is x to the power of 4. So rub this. So here verify this. D square y by dx square equals to minus x minus 2x minus into minus. So this will be plus 2x log x divided by x to the power of 4. So what happens here? This equals minus x minus 2x is minus 3x plus 2x log x by x to the power of 4. So what is common among this? X is common. I will take x common. This is our d square y by dx square. Again, that is d square y by dx square. I will take x common. So what happens here? You get minus 3 plus 2 log x by x to the power of 4. Done. So what happens here? This x one goes, so becomes x cube times. So I'll rewrite this. So that is d square y by dx square equals to what happens here. So I'll rearrange this. So can I write this? 2 log x, I'll put this, I'll send this 3 on the right hand side divided by x cube. What do you want? D square y by dx square equals to 2 log x minus 3 by x cube. What we have? We have got this, and what do we want? D square y by dx square equals to 2 log x minus 3 by x cube. We have got it. We have got it. Hence, therefore, Therefore, d square y by dx square equals to 2 log x minus 3 divided by x to the power of 3. Hence, proved. So dear students, this problem was okay. So part 2, I would like to start with some simple problems, and gradually I will go for some complicated problems, because there are some students in the classroom who are slightly weaker. So I straight away cannot get into complicated problems. Gradually I will try to increase. One more important thing I would like to share. Dear students, when I had posted long videos, I had got very good response. So it went on to 200, 266, 150, 200 and on. I tried to post small videos, that is shorter videos, and the feedback is comparatively very feeble, very less. So students are not cooperating with me to that extent. So I felt, instead of doing short videos, let me continue with big videos, because long videos will have more problems to deal compared to short videos. So let me enforce, I will do long videos itself, so that we will have number of choices and number of problems to work. And in the event you feel little bit bored up or little bit lethargic, you can stop, or you can pause at that, take a rest for a few minutes, go around one round, have a coffee, come back, again you can continue. So that's the greatest advantage when you are having a longer videos. So henceforth, by default, I'll start making longer videos and they are posted. Along with that, some important problems. In the previous problem in the class, that is class number 27, I have given a problem. I had posted a short video for 32 minutes. So wherein I have asked you, if x equals to under the root a to the power of sin inverse x and y equals under the root a to the power of cos inverse x, find dy by dx. That is a problem on parametric function. So the response is not that good, but likewise what I will do, I will try to post long videos, and here and there some important problems I will post short videos, so that you can follow that also. So dear students, we will go for the next problem. We have the next problem with us, that is y equals to x plus cot x. Show that sin square x into d square x by dx square minus 2y plus 2x equals to 0. We have to prove this. So this problem looks simple, and it's simple, but dear students, to begin with, in this initial stages, let me start with the note that some students might be just joining me for the class or something. Let them not feel it tough when I start doing some complicated problems. So what I'll do is 2 or 3 problems, I'll take some small problems or some important problems for the examination point of view, and I'll try to prepare them. So let's do this problem, and later on gradually we'll go for some delicate and complicated problems which are important for examination point of view. Any problem is important for examination, it depends upon the examiner. If the examiner intends to give this as a problem for examination, he can, but the marks will be around 4 to 5 marks. So every problem is important from examination point of view, but let us treat that all these problems are examination problems. So I have selected few good questions for you. So let's do this. So here, first, before getting the problem, try to understand the problem, how to analyze, try to analyze the problem, how to arrive at this solution. What happens here? He wants sin square into d square y by dx square minus 2y plus 2x equals to 0. It means to say that you have to differentiate this equation twice. If you differentiate, we will get to some level. From there, we will try to solve. I will show you, and I will teach you how to work out problems. So here, so differentiating with respect to x, we get what happens here, dy by dx equals to d by dx of x plus cot x. So let's differentiate this. What happens here? If we differentiate this, what happens? So this becomes 1 plus, if we differentiate plus sign is there, if we differentiate cot x, it is minus cosecant square x. So I put that within the brackets, minus cosecant square x. So this is what our dy by dx. So now what happens here? So to get this d square y by dx square, we have to differentiate this once again. So differentiating again with respect to x. What happens here? D by dx of dy by dx equals to d by dx of 1 plus into minus, plus into minus, minus, minus cosecant square x. So what I'll do? That is d square y by dx square. So if we differentiate 1, it becomes 0. So I write that because of minus. So I'll use a square bracket. So minus, if we differentiate cosecant square x, so what happens here? 2 into cosecant x into d by dx of cosecant x and d by dx of cosecant x. So what happens here? This becomes, I will neglect this, minus, this becomes 2 into cosecant x. I will write square bracket because I require that. So this becomes d by dx of cosecant x into cot x. If you differentiate cosecant, you get minus cosecant x into cot x. So what happens to this? This minus into minus becomes plus. So 2 into cosecant x into cosecant x is cosecant square x into cot x. This is what our d square y by dx square. See, now after coming to this, you have to think, because he wants the answer in sin square x, but we have here cosecant square x. So how to go about it? What you have to do? What is the reciprocal of cosecant x? 3. What is the reciprocal of cosecant x? 1 by sin x. So the reciprocal of cosecant x is 1 by sin x. What we want? We want sin square x, right? So how to go about it? I'll show you. So what I'll do? I'll write this equals to 2 into 1 by sin square x into cot x. What is this? This is our d square y by dx square. We have got this. So what he wants? He wants sin square x into d square y by dx square. If I cross multiply, what happens? We get this. And what about this cot x? From equation 1, y equals, I'll show you that. We have y equals to x plus cot x, which implies, I'll write this cot x first. Cot x equals to what happens? Y minus x. How? Okay, one step I'll write it because you may get confused. I'll write in the same way. Y, I send this y to the left hand side. This means y minus x equals to cot x, right, from this equation. That is from this equation, right? Or cot x equals to y minus x. Now what I'll do, I call this as, okay, one more step I'll take. So now I call this as equation 1. Now equation 1, we have what? D square y by dx square equals to 2 cot x by sin square x. But what is cot x? Cot x is y minus x. Done. That is d square y by dx square equals to 2 into, I substitute cot, that is y minus x by sin square x. Why? That is since cot x equals cot x equals to y minus x. Okay, so I substitute the value of cot x here. So that becomes d square y by dx square equals to d square y by dx square equals to 2 into y minus x by sin square x. Now what I'll do? I'll cross multiply. What happens here? That is sin square x into d square y by dx square equals what happens? So if you multiply this, 2y minus 2x. So we will write what he wants: sin square x into d square y by dx square, sin square x into d square y by dx square. He wants on the left hand side. I'll bring this equation to left hand side over. So what happens? Which implies, that is sin square x into d square y by dx square. This plus becomes minus here, 2y, and this becomes plus 2x equals to 0. What we want? We want minus 2y plus 2x, that is sin square x d square y by dx square minus 2y plus 2x equals to 0. So we have sin square x d square y by dx square minus 2y plus 2x equals to 0. Hence proved. We have got it. Such a simple problem. So hence proved. So dear students, this is a way you have to work out problems, very simple problems. So to begin with, we'll start with simple problems and gradually increase its depth. So let's go to the next problem. Students, we have a problem here. Our next problem is, if y equals a sin mx plus b cos mx, prove that or show that d square y by dx square plus m square y equals to 0. So it's a very simple problem, but this problem also keeps repeating for 4 marks or sometimes 5 marks also. So very simple. If the examiner is good enough, kind enough, he will definitely give this problem to you for the next exam. So let's solve this. Differentiating with respect to x, that is dy by dx equals to d by dx of a sin mx plus b cos mx. So what I will do is, this is nothing but a sum rule. I will try to split it. So what I will do, this is equals to d by, I will take this a outside, okay, this is a into d by dx of sin mx plus b into d by dx of cos mx. What happens here? So if you differentiate this, this becomes a, if you differentiate this becomes cos mx into m, derivative of this, so plus b into minus sin mx into m, sin mx into m. So what I will do is, I will try to take this m as common. What is this? This is our dy by dx, dy by dx. So this is equals to what? M I will take common. So I will write like this. So this becomes a cos mx plus, is there minus into plus, it becomes minus into plus becomes minus b cos, sorry, b sin mx, b sin mx. What is this? This is our dy by dx. What he wants? He wants prove that d square y by dx square plus m square y equals to 0. So what does it mean? You have to differentiate this equation once again. So I rub this. I rub this too. So I call this as equation 1. Differentiating equation 1 once again with respect to x, we get what? That is d by dx of dy by dx equals to m into d by dx of a cos mx minus b sin mx. I wrote this. So on the left hand side, what happens here? This becomes, if you differentiate d by dx or dy by dx becomes d square y by dx square. So what I will do? I will take this m outside. So what I will do? I will take this a. So cos of differentiation will be what? This will be minus sin mx into m. If you differentiate cos mx, we get minus sin mx into m. So we have a minus sign here. I take this b outside. So I close this bracket. Minus, I open this bracket once again, b into, I do like this. So this becomes, I will take b outside. So if we differentiate sin mx, we get cos mx into m. This becomes cos mx into m. So rub this. So once again I take this m outside. What happens here? We have minus sign both sides. I take minus. So this m, once it comes out into m, it becomes m square. So this becomes a sin mx plus b cos mx, and on the left hand side we have d square y by dx square. What is a sin mx plus b cos mx? It is nothing but our y, right? So you know how did you get this minus here? We have minus sign here, we have minus sign here. I have taken that minus sign common. We have one m here, and for this also we have, if you take that m common outside, this becomes m into m, that is m square and minus sign. So if you multiply and see, again you get minus sin mx, you get minus sign, and minus into plus becomes once again minus. So our assumption is right. So what I do, next line, so I write this, I rub this to, that is d square y by dx square is equals to minus m square, and I will call this as y. Right? Since a sin mx plus b cos mx equals to y. So I have substituted the value here. We have this, I call this as equation 2. I rub this, by substitute, okay, anyways understood. So I rub this. So this means what? He wants d square y by dx square plus m square y equals 0. So we have m square y, if I bring it to the left hand side, we get plus m square by y, m square into y. So that is d square y by dx square. If I bring it to the left hand side, it becomes m square y equals to 0. What he wants? Therefore, d square y by dx square equals to, plus m square y equals to 0. Hence proved. So this is a simple problem. If the examiner is kind enough, he might give you this problem. So you can least expect this. So anyway, good luck for this problem. So dear students, we'll go for the next problem. Dear students, we have a problem here. Y equals e to the power of ax into sin bx. Show that d square y by dx square minus 2a into dy by dx into a square plus b square into y equals to 0. This problem keeps repeating in most of the examinations. So this problem, the examiner wants to test you how much, to what extent you have understood differentiation, because if you are able to do this, because it's confusing, so it's tricky. So you have to have a lot of patience while doing this problem. Though this one looks simple, but it is tricky. So don't lose hopes, we shall solve this problem in an easier way. So dear students, let's solve this. So what happens here? We have to use product rule, because we have two functions, e to the power of ax into sin bx. Use product rule and let's solve this problem. So differentiating with respect to x. See here, why I am writing with respect to x. In the previous class, that is class number 26-27, we have used parametric functions, differentiation, that is to differentiate with respect to theta or t, because we had to, that is two functions, that is x equals so much and y equals so much. So that concept is not here. We have a straightforward question, y equals to e to the power of ax into sin bx. So here we are going to differentiate only with respect to x. Done. So what happens here? dy by dx equals to d by dx of e to the power of ax into sin bx. So let's see this product rule, and product rule, that is first function I will keep as it is, d by dx of sin bx plus sin bx into d by dx of e to the power of ax. So what happens here? This becomes e to the power of ax, that is dy by dx equals to, if we differentiate sin bx, it will be cos bx into b, that becomes cos bx into b plus sin bx into e to the power of ax is e to the power of ax into a. I rearrange this. So that happens, what happens? I take this b outside on the other side. So this is b into e to the power of ax into cos of bx. I take this plus a into e to the power of ax into sin bx. Let me call this equation 1. Done. And what is this? E to the power of ax into sin bx. What is this? That is nothing but our y. If you go on doing this, this continues. So what you have to do, you have to be a little bit tricky here. So replace this with y. In the event you solve this problem, again you have to use product rule. So you will go again, after some time you get in terms of cos again you will have to differentiate this, continues, the process continues. So at this point of time you replace this with a. Most of the students, they go wrong, they go on doing it, waste their time and give the paper later on. Don't do that, replace this. I will show you how to do it. So what happens to this? You have copied this. Okay, I love this. So let me, anyway, this is our equation 1. Equation 1. I'll rub this. So what I'll do? dy by dx equals to b into e to the power of ax into cos bx plus a into y, because this is nothing but y. I replace that with y. I call this as equation so here, since y equals e to the power of ax into sin bx, okay, I call this as equation 2. Done. So this y is because of e to the power of ax. I have shown you this. Now I call this equation as 2 and this equation as 1. So I will differentiate equation 2 once again. What happens here? Differentiating equation 2 again. Okay, anyway it's again what? Differentiate equation 2 with respect to x. So that is d by dx of dy by dx equals to d by dx of b cos b into e to the power of ax, e to the power of ax into cos bx plus ay. I love this. So here you have to use product rule, that is b into e to the power of ax. I will take this b common outside and use bracket for this, that is d by dx of cos bx plus cos bx into d by dx of e to the power of ax plus d by dx of I take this a outside, a into d by dx of y. Now if I put this, that will be for that also, so that b will become for this. So this b is only for this much, no b is here. So what I will do? So I have done that, separate d by dx of d by dx of y, because if I put that within if I put the bracket here, this b will be for everything. So let me split it. So what happens here? So if we differentiate this, b into e to the power of ax, d by dx of cos x is minus sin bx into b. This becomes what? Minus sin bx into b plus cos bx, d by d of this becomes e to the power of ax into a plus a into dy by dx. If you differentiate d by dx of y will be dy by dx. I love this. I will retain that equation 1 and 2 as it is. I will carry from here. So this becomes what? Finally, d square y by dx square equals to this b into this b, it becomes and minus, this becomes minus b square into e to the power of ax into sin bx. Sin bx, I'll use a bracket, plus this a into b cos, no, e to the power of x, e to the power of ax into cos bx plus a dy by dx. You followed what I have done? I have taken this minus value outside, this b into this b becomes b square e to the power of ax sin bx, this sign minus sign is here, plus you have a and this b, so this b into a is ab into e to the power of ax cos bx plus a dy by dx. Just go through this. So dear students, what I will do is, I will group this. Now what is this and this? From this, e to the power of ax into sin bx is nothing but our y, right? And what about this? This will be dy by dx minus, if you want, from this b into e to the power of ax cos bx. So if you remove this, you will have what? I will show you this. Next step, I will rub this. So d square y by dx square equals to comes b square into y, because this is nothing but y equals e to the power of ax into sin bx. So I am going to replace this into y plus a into this becomes dy by dx minus ay plus a into dy by dx from equation 1 and equation 2. I will show you this. I will rub this. Okay. Now supposing I replace this with e to the power of ax into sin bx, right? This is our equation 2, isn't it? So now what happens? If you minus b into e to the power of ax into cos bx plus a into e to the power of ax into sin bx, isn't it? That is our equation 2. Now supposing I will move this to the right hand side, this becomes dy by, if I move this to the left hand side, this becomes a into y equals to what? B into e to the power of ax into cos bx, correct? What is b into e to the power of a cos bx? So what is this? B into e to the power of ax into cos bx is nothing but dy by dx minus ay. Look at this. So finally what happens? This becomes minus b square y. This is b square y. A into what is b into e to the power of x cos bx is nothing but dy by dx minus ay. That's what I replaced here. So plus a into dy by dx. Okay, friends, I am clear? Okay, that equals to minus b square y plus a into dy by dx plus into minus minus a square y plus a into dy by dx. So what I have done? I have taken this minus b square by y like this. I have multiplied this a into dy by dx dy by plus into minus minus a into a square into y plus a dy by dx. Yes, we are clear here. So what he wants? 2a. So we'll add this. So d square y by dx square equals to minus b square y 1a dy, and this becomes 2 plus 2 a dy by dx, left with what? Minus a square y. So this is equals to d square y by dx square equals to 2a into dy by dx minus a square y minus b square y. I have rearranged it. So what is common here? Minus y is common. D square y by dx square equals to 2a dy by dx minus y. This becomes a square plus b square. So he wants on the left hand side 0, on the right hand he wants 0. The remaining portions he wants on the left hand side. Let's transfer it. That is d square y by d square. If you bring it to left hand side, what happens? It becomes minus 2a dy by dx. This minus becomes, dear students, make a correction here. This is plus a square b into y. Because it not happen without this plus, it is not possible because we have this. So this minus, it becomes plus y into a square plus b square. See, while writing the question, I forgot to add this plus, make that correction in the question. So, but for this, it is not possible to solve the problem. We need to have a plus sign. By mistake, I had not put this plus, make a plus there. But he wants like that, d square by dx square, d square by square minus 2a by dy dx, d square y by dx square minus 2a into dy by dx, 2a into dy by dx plus a square plus b square into y. But if I have taken this side, okay, we write it once again. So this can be written as d square y by dx square minus 2a dy by dx plus a square plus b square into y equals to 0. Sorry, no 0 here, equals 0. Hence proved. Dear students, this problem looked simple, and it is simple, but we have to use a trick here. What I told you, substitute the value of dy by dx as well as a, and that is y. Otherwise you have to substitute wherever in the equation 1 and 2 you have to substitute the values of y, that is y equals e to the power of ax into sin bx, that you have to replace it, and later on that thing dy by dx means ay. If you don't do that, you will go on continuing till infinity, that the never ending story. So that trick has to be employed while solving this problem. So be careful while solving this problem, have lot of patience, you can do it, because the trick is very nice here. So please follow this, very important problem. This can be an examination problem, because very important and very interesting problem. This is confusing and it is really interesting problem. So let's go to next problem. We have one more problem. Y equals tan x plus secant x. Prove that d square y by dx square equals to cos x by 1 minus sin x the whole square. So this is a nice problem. Let's solve this. So what we'll do, we'll differentiate this. Given, so straight away we'll differentiate this. So by differentiating with respect to x, we get what? Dy by dx equals to d by dx of tan x plus secant x. So what happens here? This equals, if you differentiate tan x, we get secant square x plus, if you differentiate secant x, this will be secant x into tan x. If you differentiate, this will be secant x into tan x. D by dx of secant x is secant x into tan x. So what I will do, I will try to bring it, because you want in terms of cos x. So I will bring everything in terms of cos x. So this equals to, that is what? Dy by dx equals to what? Secant square is nothing, what is reciprocal of secant x? Secant x is 1 by cos x. So secant square x will be 1 by cos square x. So can I write this as 1 by cos square x plus secant x also I will write in terms of 1 by cos x into tan x I will write into sin x by cos x. So everything I brought it in terms of cos x. So what shall I do? I do nothing but 1 by cos x, cos square x plus sin x by cos x into cos x, cos square x. So LCM is cos square x So now dy by dx equals to, I take LCM. LCM is cos square x. Cos square x goes one time, so I'll write 1 plus cos square goes, this becomes sin x. That is nothing but dy by dx equals to 1 plus sin x by cos square x. We know that, I'll write this also, sin square x plus cos square equals 1, or cos square x equals to 1 minus sin square x. So what I'll do, I'll substitute the value of cos square as 1 minus sin square x, because I want to cancel this. So this becomes 1 plus sin x by 1 minus sin square x, since cos square x equals to 1 minus sin square x. I use that relation. Now what I'll do is, this is our dy by dx. This is of the form, can I write this as 1 square minus sin square x? Yes, why not? So that becomes a square minus b square. See, the concept is, try to solve this so that the numerator should be 1 or something. Try to remove this numerator so that bring it to this one. So I'll show you how to do it, because we have to differentiate d square by dx square. So if you take quotient rule here itself, it will be difficult for you to solve. Bring it to the easiest form. What? I'll show you how to go about it. So what I'll do, dy by dx equals to, I'll write this 1 plus sin x divided by a plus b into a minus b, that is 1 plus sin x into 1 minus sin x. Can I write like this? So this and this cancels, that is dy by dx equals to 1 by 1 minus sin x to the power of 1. So what I'll do is, I'll try to bring it to a standard form. So what this can be written as what? Which is nothing but 1 minus sin x to the power of minus 1. Can I write like this? Yes. That is dy by dx equals to 1 minus sin x to the power of 1. I call this as equation 1. So I'll differentiate equation 1 once again, because I need d square y by dx square. So that is differentiating equation 1 again with respect to x. What happens? That is d by dx of dy by dx equals d by dx of 1 minus sin x to the power of minus 1. This equals to minus 1 into 1 minus sin x to the power of minus 1 d by dx of dy dx of 1 is 0. So dy dx of minus sin x, dy dx of minus sin x. D square y by dx square. Is it visible? Yeah. So what happens here? We have minus sign here and minus sign. Minus into minus becomes plus. So d square y by dx equals to minus one becomes this 1 minus sin x to the power of minus 2. Minus 1 is become minus 2, and dy dx of sin x is cos x into cos x. So what I will do, I will send this to the denominator. So this equals to what? 1 by 1 minus sin x into cos x. I will rearrange it properly. That is d square y by dx square equals to cos x by 1 minus sin x the whole square. What do you want? You want to prove t square y by dx square equals to cos x by 1 minus sin x the whole square. So we got d square y by dx square equals cos x by 1 minus sin x the whole square. So hence proved. Hence proved. So dear students, the simple problem, when you see it, you will not think about bring it to the form of by cos 1 by cos. So you will go on differentiating this and you will not get the result. So you should learn the tactics, how to arrive at this. So I have taught you the techniques. Try to use that technique, and so we will go to the next problem. Students, we have a problem. If y equals to sin inverse x, prove that y2 equals x divided by 1 minus x square to the power of 3 by 2. Or sometimes the question be asked like this: 1 minus x square into y2 minus x y1 equals to 0. Either they may ask you to prove like this or like this, but the problem is very simple. Let's differentiate this. If you know differentiation, you can easily prove this, but for this you have to use little trick which I am going to teach you now. So dear students, let us take this differentiating with respect to y. So differentiating with respect to x. Here once again I tell you, we are dealing with successive differentiation, not parametric functions, where in parametric we have to differentiate with respect to t or theta, but here with respect to x. Even if you don't write, it is understood we are differentiating this with respect to x, because I am going to use d by dx of. So the moment you see that d by dx of means to say we are differentiating it with respect to x. That's clear? Okay. Now what happens here? Dy by dx equals to d by dx of sin inverse x, sin inverse x. So it is a simple problem. We should know the formula for d by dx of sin inverse x. What is d by dx? So I will write here d by dx of sin inverse x is the inverse function. So this becomes what? 1 by under the root 1 minus x square. So d by dx of sin inverse x is Supposing if you have cos inverse, you will get a minus value. Since it is sin inverse, so you don't have any minus value for this. So what happens to this? This becomes what? 1 by under the root 1 minus x square. So this is our dy by dx. I call this as equation 1. So we are supposed to find y2. What does y2 indicates? It is nothing but d square y by dx square. So what we have to do? We have to differentiate this equation 1 once again. Then only we will be able to solve this. But here this is not of standard form. Please bring it to a standard form and then differentiate. So how to bring it to a standard form? I have already dealt these problems in the initial stages. If you want, you can go back and refer it, or I will teach you here itself on 2 lines, no problem. So it involves 2 steps. So what I will do, this is nothing but 1 by 1 minus x square to the power of half. Can I write like this? So if you want to remove the root, but you have to put to the power half. It was cube root, it will be 1 by 3. If it is 4th root, 1 by 4. Depending upon if it is nth root, 1 by n. So depending upon the root, we have to take this. Now as it is, it's a square root. So square root means to the power of half. So you know we cannot differentiate this, we have to bring it to standard form. What I will do, this is nothing but which is equals to what? That is, if I bring it to a numerator, to the power of minus half. Can I do this? So finally dy by dx will be 1 minus x square to the power of minus half. So from this we can differentiate now. What happens here? That is dy by dx equals to 1 minus x square to the power of minus half. Now let's differentiate this. So I'll rub this. So this is our equation 1, because we need that. Let us not rub that. So I'll rub this also. So what happens here? We have dy by dx equals to 1 minus x square to the power of minus half. Now differentiating again, with respect to x. What happens here? That is d by dx of dy by dx equals to d by dx of 1 minus x square to the power of minus half. So I will rub this, students. So how to differentiate this? I will show you. This is nothing but minus half into 1 minus x square to the power of minus half minus 1. Minus half minus 1, because into d by dx of minus x, that is will be into minus, I write one step, into d by dx of minus x square. So what happens is, this is nothing but minus half into 1 minus x square. Half minus 1 is minus 1 and half, 1 and half is nothing but minus 3 by 2. Minus 3 by 2 into minus 2x. If you differentiate x square minus x square, it becomes minus 2x. See here, you might be asking, how did you get 3 by 2? Minus half minus 1 by 1. 2 is the LCM. 2 goes 1 time. So minus 1 minus, it goes 2 times, that is 2, minus 3 by 2. Done. So I will rub this. So what happens here? minus into minus plus this 2 and this 2 cancels. I'll rub this. So minus into minus plus, what is this? Our d square y by dx square, that is d square y by dx square, which is nothing but y2, it is also called y2, equals to, so I'll cancel this 2 here itself and here, and this will become minus into minus plus as it is, I need not write that, x into 1 minus x square to the power of minus 3 by 2. Supposing I send this to the denominator, what happens? We get this. So that is y2 equals to x by 1 minus x square to the power of 3 by 2. What he has asked you? To prove that y2 equals x by 1 minus x square to the power of 3 by 2. We have got it. y2 equals to x by 1 minus x square by 2. So this portion is over. 50% or 60% of the problem is over. Now in the event if they ask you how to solve this, I'll teach you. I'll rub this. Many things I know do. I'll call this as equation 2. So I'll write this y2 equals to, I'll write this x divided by, can I write this 1 minus x square to the power of 1 into 1 minus x square to the power of half what I have done, this 3 by 2 I have split. If you add this, bases are same. If you add the indices, what happens? 1 plus 1.5 is nothing but 3 by 2. So I have split this. See, to prove I am proving this here if you want. So now this can be written as what? This can be written as x by 1 minus x square. Near 1 I need not write. I need not write y. This, what is root x is nothing but x to the power of half, or x to the power of half is nothing but root x. Can I write like that? Yes sir, why not? So this happens under the root 1 minus x square. Done. So y2 equals to x by 1 minus x square into under the root 1 minus x square, right? I call this as equation 3. Okay, I'll rub this. That is from equation 3 we have what? y2 equals to x by 1 minus x square into 1 by under the root 1 minus x square. Can I write like this? I have shifted this. If you remember, if you take LCM or if you take, once again you get the same thing. So I have to, but what is this value? What is this value? That is nothing but our y1, isn't it? What is it? D by dx of sin inverse is nothing but this, what we have proved. So this is our y1. So I'll rub this. I rub this also. So y2 equals to x by 1 minus x square into y1, right? Because since y1 equals to under the root 1 minus x square. Done. So y1. So what he wants? He wants 1 minus x square into y2 minus x y1 equals to 0. We have already got it. So if I cross multiply, what happens here? That is how he wants. He wants 1 minus. So 1 minus x square into y2 equals to x y1. So x1 y1 is plus, it is on the right hand side. So if I bring it to the left hand side, we get that. Simple. So that is 1 minus x square into y2, I will bring it to the left hand side, minus x y1 equals to 0. So this is nothing but this, hence proved. This is our answer. So dear students, this problem was simple. This part definitely, with your experience, whatever I taught you, you will be able to solve this problem. But for this, you may require a little bit of push, which I have given you. So dear students, all the problems are simple. Only thing you have to use your mind and your willpower to attempt to this problem and solve it. If you have that, definitely you can do any problem. No problem is impossible. For every problem, there is a solution. Only thing needs your interest and your dedication, your hard work and your interest to do it. So we are finished. Let's go to another problem. So dear students, we have one more interesting problem. Y equals a cos of log x plus b sin of log x. Prove that x square into y2 plus x y1 plus plus y equals to 0. So here students, this is a what? Composite function. So let's solve it. Very simple problem. I hope you have not forgotten composite functions. Let's solve. So here, differentiating with respect to x, so that is dy by dx equals to dy dx of a cos log x plus b sin log x, and close up bracket. So dear students, I have not written differential with respect to x because it is obvious, it is understood here. The moment you write d by dx, it means you are differentiating this with respect to x. In the examination you can start straight away like this, but it's better to write differentiating with respect to x. That is a good way of writing, but since I have already missed it, so you please add it on. So what happens here? Dy by dx equals to, if you differentiate cos log x, what happens? So I get minus, that is equals to minus a sin log x plus b into log x, that is d by dx or log x is 1 by x plus b into cos of, if you differentiate sin x, you get cos log x into 1 by x. So what I will do, I take 1 by x common, that is dy by dx equals to, I will write this 1 by x common, that is dy by dx equals to 1 by x 1 by 1 by x common, that becomes minus a into sin log x plus b into cos log x, because I have already taken 1 by x here. So I call this dy by dx nothing but y1. So I'll write like this, instead of writing dy by dx I'll write this y1. I cross multiply this here, I'll cross multiply into x equals to what? Minus a into sin of log x plus b into cos log x. What I have done? I have multiplied this. So I call this as equation 1. So d by dx of y1 equals to d by dx of minus a sin of log x plus b of cos log x. I rub this, because that line was not visible, so I have rewritten it once again. So when x is here into x, when x was there, x into y1. So what happens here? We have to use product rule. Let's use product rule. That is y1 into d by dx of x plus x into d by dx of y1 equals to, so here a, this becomes minus a cos log x plus b into 1 by x, sorry I am forgetting 1 by x, into 1 by x plus b, this becomes differentiation of cos x is minus sin, that is minus sin log x into 1 by x. So what I will do, this minus sign I will take common and I will take this 1 by x common. So that is, so if we differentiate x, it becomes y1 into 1 plus x, d by dx of y1 is, it becomes y2 equals to, I will take minus 1 by minus sign value, minus sign common and 1 by x common. So this becomes a cos log x plus, I have taken this minus in common, so b sin log x. What is this? A cos log x plus b sin log x is nothing but our y. So what I do? I cross multiply this once again. What happens here? If you cross multiply this, okay, one more step. So by cross multiplying, what happens? X y1, because it has to be multiplied for both, this becomes x square y2 equals to minus y, because this x has gone to this, so x into x1 y1 plus again x into x, it becomes x square y2 equals to, what is this? This is nothing but our y. You can write if you want, since y equals to a cos log x plus b sin log x. So what has happened here? X y1 x plus x square plus equals to minus y. If you bring it here, what he wants, prove that whatever it is x square y2 plus x y1 plus y. We have got it. So only thing I have to rearrange it. So I'll rub this. I'll write this as equation. I don't know equation 2 or 3, whatever it is. I'll write equation 3. It should be 1 or 2 or 3, 1 or whatever it is. I call it the equation 3. So by rearranging equation 3, we get what we get? The answer. So first term we want x2 y2 x square y2. We will rearrange this. So that is x square y2 plus x y1 plus x y1. So minus sign, if I bring it to the left hand side, it becomes plus. On the right hand side, what will have? 0. So what is this? Therefore y equals a cos of, that is a cos of log x plus b sin of log x equals to what? This answer, that is x square y2 plus x y1 plus y equals to 0. So I'll rub this. Hence proved. So dear students, if you have learned differentiation, whatever I have taught, you can easily solve this, provided you know the formula, the methods. Otherwise, no. So let's go for next problem. Y equals x into cosecant inverse x. Here it is a inverse function which we have to use using, we have to solve, we have to differentiate using product rule. So let's start. Not a big issue, it's a simple problem. Only thing we should know, if you differentiate cosecant inverse x, what do you get? So what we'll do, we'll use product rule, differentiating with respect to x, we get what? Dy by dx equals to d by dx of x into cosecant inverse x. So we will use product rule, that is nothing but x as it is, d by dx of cosecant inverse x plus cosecant inverse x minus d by into d by dx of x. So what happens here? Now remember, d by dx of cosecant inverse x is what? Minus 1 by x into under the root x square minus 1. So dear students, you should remember this formula. This formula is an important formula, inverse functions. So I have done few problems earlier. I have given a formula for all the functions in my class number 1. So go back to my class number 1 and try to solve this, try to memorize this formulae. Otherwise you cannot solve any problem if you don't know the formula. So let's go ahead. So what happens to this? This becomes x into d by dx inverse is nothing but, I'll use bracket, minus 1 by x into x square minus 1 plus cosecant inverse x into 1, d by dx of x is 1. So what happens here? This is our y1. So this x cancels. So y1 equals to minus 1 by x square minus 1 into, plus cosecant inverse x. It's not writing. Plus cosecant inverse x. I call this as equation 1. I have this. y1 equals to minus 1 by under the root x square minus 1 plus cosecant inverse x. So what I'll do? So please note, dear students, this is not a standard form. This can be differentiable. This is differentiable, but this is hard to differentiate. What you have to do? You have to bring it to standard form. So what I'll do? I'll try to simplify this. So this is minus 1. I write this x square minus 1 to the power of half plus cosecant inverse x. So even now it's difficult to, it is not possible to differentiate because not a standard form, but this is more or less standard, d by dx of 1 by ax plus b of that form. So we'll simplify this. So I'll do this. Minus 1, I'll take it outside, that is x to the power of 2 minus 1 to the power of minus half plus cosecant inverse x. Done. So what is this? This is our y1. y1 equals to this, because I am trying to simplify this. I brought it to the numerator, so this plus sign becomes minus half. Now differentiating, I call this as equation 1. I call this as equation 1. Differentiating equation 1 with respect to x. What happens? D by dx of y1 equals to d by dx of minus x square minus 1 to the power of to the power of minus half plus d by dx of cosecant inverse x. I will take this minus sign outside. So, if you differentiate this, minus half into x square minus 1 to the power of minus half minus 1 into d by dx of x square plus d by dx of this will be what? This will be minus 1 by x into under the root x square minus 1. What happens to this? This becomes minus, this is y2 equals to minus half into x to the power of x square minus 1 to the power of minus 3 by 2 into 2x minus 1 by x into x square minus 1. So this minus into plus becomes minus. So 1 by x into x square minus 1. So here what happens? This 2 and this 2 cancels, and this minus into minus becomes plus. So x, this becomes x into x square minus 1 to the power of minus 3 by 2 minus 1 by x into x square minus 1. This is into. So what I will do? I will send this to the denominator. What happens? So y2 is equals x by x square minus 1 to the power of 3 by 2 minus 1 by under the root x square minus 1 into x 1 by x into x square minus 1. That is y2 equals to what happens here? X by square root of x square minus 1 whole to the power 3 minus 1 by x square minus 1. This is the required answer. So dear students, you can stop at this. It's a very important problem, but you can stop at this. Let's go for the next problem. It's a simple problem, nothing to explain, it is self-explanatory. So you can do yourself. Only thing you should know the procedure and how to simplify this. If you know to simplify, this problem is yours. So dear students, we have a problem here. If y equals x into log of x by a plus bx, prove that x cube into d square y by dx equals to x into dy by dx minus y whole to the power of 2. So this is a very good problem, and if you can solve this problem on your own, hats off to you. It is not a difficult problem, it's a very simple problem. Only thing, you have to use your hard disk, your mind, because this problem is really tricky and very nice problem. So you should be able to solve this problem on your own by now, because you are well versed with sum rule, difference rule, composite functions, quotient rule, product rule, implicit functions, parametric functions, successive differentiation. What else you want? You are well versed. You have to work out this. Anyway, I am there to help you out in solving this problem. Let me help you. So let's start. So dear students, here we cannot straight away solve this problem. We have to use a small trick here. So let's see what it is. Given y equals x into log of x divided by a plus bx, right? So how will you go about this? So I call this as equation 1. Okay, what I will do is I will simplify this. This is nothing but y by x. I bring this x down, equals to what? Log of a minus log of a plus bx. I will put this within a bracket. So what concept I have used here? You know that log a by b equals to log a minus log b. So log of a by b, so that is log a minus log b. I have used that concept here. Let's solve this. So what happens here? So I call this as equation 2. Now differentiating equation 2 with respect to x, we get what happens here. Use quotient rule here. So what happens here? I will use, that is x the whole square, x into d by dx of y minus y into d by dx of x on the left hand side, and on the right hand side we have, this is, if you differentiate log x, sorry, this is log x. So this is log x because I wrote that, that's why I got confused. So if you differentiate log x, we get 1 by x minus this is 1 by a plus bx and d by dx of a plus bx. I rub this. I have this also. What happens here? This is x into d by dx of I is dy by dx dx minus y into 1 by x square, we have this x square denominator, equals to 1 by x minus 1 by a plus bx dy dx of this becomes a dy dx of a constant is 0, and if we keep this for that example, d by dx of a plus bx, what happens here? D by dx of a plus b I'll keep outside, d by dx of x. So this is 0 plus b outside, d by dx of x is 1, so we get only b. So what happens here? Into b. I love this. This is x into dy by dx minus y by x square equals to 1 by x minus b by a plus bx. So at this stage I will take LCM, that is x into dy by dx minus y divided by x square equals to, I will take LCM is x into a plus bx. What happens? X cancels, we will have left it a plus bx. A plus bx into 1 is, this is a plus bx, and a plus bx goes, and then we left it minus bx, right? I rub this. I rub this too. What happens here? 1x and 1x cancels here, and we have plus bx and minus bx cancels. We are left with what? That is x dy by dx minus y, left with x equals to a by a plus bx. bx. What I will do, I will cross multiply this. So what happens to this? That is x into dy by dx minus y equals to ax by a plus bx. I call this as equation 2. So what I will do is, I will differentiate this equation once again, because I want d square y by dx square. So what I will do, differentiating equation 2 with respect to x, we get, what happens here? Yes, here also we have two functions, we will use product rule here. This becomes x into, this will be, keep this d by dy by dx of dy by dx plus I keep this dy by dx into, sorry, I keep the second function as it is into d by dx of x minus d by dx of y equals to, on the right hand side, so here I have kept x as it is, d by dx of dy by dx plus I have kept dy by dx as it is and differentiated second function d by dx of x minus d by dx of y. Now we will come to the right hand side. So right hand side what we will do? We will use quotient rule. What happens here? I will rub this. So quotient rule. So here what happens here? So I use a plus bx the whole square. So what I will do? A plus bx into d by dx of ax minus ax into d by dx of a plus bx. I will rub this. I rub this also. So what happens here? This is, if you this becomes x into d by dx of dy by dx is d square y by dx square plus dy by dx into 1, I will ignore that, minus dy by dx of y is dy by dx, dy by dx. On the right hand side we have a plus bx, d by dx of x is, a is constant, I will take it outside, d by dx of x is 1, so into a minus ax, d by dx of this becomes what? Into b. So I repeat, a plus bx I have written as it is, d by dx of ax, so a I take it outside, then d by dx of x is 1, so it becomes x into 1, so I have said I have written a minus ax I have taken as it is, d by dx of a is 0 plus b I will take it outside, d by dx of x is 1 once again. So divided by, what is that? A plus bx the whole square. I love this. We have here plus dy by dx cancels, minus dy by dx cancels. So we will simplify that. That is x into d square y by dx square equals to, I will multiply this, a into a square, and this becomes plus abx minus abx divided by a plus bx whole to the power of 2. I will rub this. So here again you have plus abx and minus abx. So this cancels, this cancels. You are left with what? X into d square y by dx square equals to a square by a plus bx. So dear students, note here in the problem he has asked you what is that? X into d square y by dx square equals to a square by a plus bx the whole square. He wants x cube. What will you do? Multiply both sides by x square. What happens then? We get x cube. So I'll rub this. I call this as equation 3. Multiply equation 3 by x square on both sides. We get what happens here? I love this. If you multiply x square, it becomes x square into x d square y by dx square equals to x square into a square by a square by a plus bx the whole square. I rub this. Okay, one more step. X into x, x square into x, this is x cube into d square y by dx square equals to a square x square by a plus bx the whole square. I rub this. So this can further be written as what? X cube d square y d square, I can write this as ax plus a plus bx the whole square. Can I write like this? Ax plus, so what I have done, I made this whole square, because even if you solve this, you will get back the same answer. So now from equation 2, we have rubbed equation 2. So what is equation 2 now? So I'll try to see, I had lack of space, I have forgot. So equation 2, I'll try to solve that and show you once again. From equation 2, what was then equation 2, I don't know, because I already rubbed it. So I'll come back to that. I'll solve that equation 2 and substitute here. We have y equals x log of x by a plus bx, isn't it? That is y by x equals to log x minus log a plus bx. I already done this. I have to go back because I need this equation. So once again I am trying to show you how I got this. So here what we did, we took a quotient rule and we solved it. That is x square, that is x into d by dx of y minus y into d by dx of 1, isn't it, equals to 1 by x minus 1 by a plus bx into b. That was so this is x into dy by dx minus y by x square equals to 1 by x minus b by a plus b x isn't it? So what had happened here? So x into dy by dx minus y equals to LCM was 1 into a plus bx. So that was a plus bx minus bx, correct, divided by x square. So I'll rub this. So 1x cancelled. So this was x into dy by dx minus y equals to this plus bx minus bx, that is a by divided by here 1x, a plus bx. I rub this. So what had happened here? I will send this a there, x to the numerator, that becomes x into dy by dx minus y equals to ax by what? A plus bx. So what is ax by a plus bx is nothing but x into dy by dx minus y. Can I replace this? So I'll rub this. Yes, why not, sir? Please rub it and finish the problem as early as possible. So what I'll do, I have whatever I had done earlier, I have done it once again to show you. I have to substitute this value. In the event straight away substitute, you get confused. That's why I have worked this problem, that equation to once again to show you. I am going to replace this with this. Alright. So what happens is, so now I'll replace that. So that is nothing but x cube that is x cube into d square y by dx square equals to that is x into dy by dx minus y the whole square. What he wants? S cube into d square y by dx square should equals to x into dy by dx minus y the whole square. Don't you think we have reached it? We have got it? So dear students, I'll rub this. So therefore x cube into d square y by dx square equals to x into dy by dx minus y the whole square. Hence proved. Dear students, this problem looked difficult, right? You felt it difficult, but don't you think it's very easy? So there are some techniques which you need to adopt to solve this problem. Straight away you cannot sit in the examination and start doing this problem. It needs practice. So without practice you cannot progress. So please practice and try to work it out once again. Sit at the table tightly and try to do. See, I am one person who dedicates, who works very hard to see that I give the best to you, because I'll be sitting right from morning to evening when I'm in the college. I'll be working out some problems for the students. I'm trying to select some problems for the students so that they finish well, they do well. So I put a lot of hard work. So I also, if to reach to this stage to teach you, I have really बहुत पापड़ बेले हैं, बहुत मेहनत किया है हम लोगों ने. मेहनत इतना किया है कि सवेरे 8 बजे से लेकर रात के 11 बजे 12 बजे तक पढ़ते थे. So I have struggled, I have studied with lot of honesty, hard work, dedication. So without that you cannot. So dear students, what I suggest you, what I advise you, what I request you is please work hard, because your parents are behind you to support you. I didn't have anybody to support me. I have come the very hard way. I had to give tuitions for my younger ones, to my juniors, prepare them out of the money I used to earn. I have to pay my fees and I have studied with lot of difficulty. We did not have money even to pay electricity bill. I used to sit outside, go to my friend's circle, sit in their house and study. They used to sleep, but I used to work hard. Because of that I am here. So tomorrow I want you to be here and teach others, spread your knowledge. It really needs lot of dedication, lot of hard work. Without that you cannot. See, dear students, I have been putting very hard work. I have been doing good for you. Don't you think it's your duty to reciprocate? As such, please like, share and subscribe to my channel, because for the hard work what I am putting, don't you think I deserve you to subscribe to my channel? Yes, you have to. Be sincere. You touch your heart and say, sir is putting so much of effort to teach us. It's our duty to help him. Please try to subscribe to my channel. So dear students, this problem, I'll try to give more problems and try to work very good interesting problems. One of the examinations problems. So you can definitely expect 8 marks or 6 marks, the maximum marks. This is definitely truly an examination problem. So you can anticipate, you can expect this problem for the examination. So I'll put star for this problem. 3 stars. So this is an important problem. Please work hard once again. So let's go to the next problem, dear students. I hope you will subscribe, share and like my videos. So yes students, we'll go ahead. Dear students, we have a problem if y equals x plus under the root x square minus 1 whole to the power of n, prove that x square minus 1 into y2 plus xy1 minus n square y equals to 0. So this is a good problem, simple, tricky, and we can definitely do this. You can do this. So let's start. So what is the given y equals x plus under the root x square minus 1 to the power of n, isn't it? So differentiating with respect to x, we get what happens here, dy by dx equals to d by dx of x plus under the root x square minus 1 to the power of n. So very simple problem, this of the type x to the power of n type. So if you differentiate this, what happens here, this becomes dy by dx equals to n into x plus under the root x square minus 1 to the power of n minus 1 into d by dx of x plus under the root x square minus 1. So I do it here. What happens here? dy by dx equals to n into x to the power of x plus under the root x square minus 1 to the power of n minus 1. d by dx of this is nothing but one plus d by dx of this is half x square minus 1 into d by dx of x square. So what happens to this? dy by dx equals to n into x plus under the root x square minus 1 n minus 1. This becomes 1 plus half into x square minus 1. d by dx of x square is 2x into 2x. So this is nothing but, dy by dx equals to n into x plus under the root x square minus 1 to the power of n minus 1. So the square bracket, So this two cancels. You are left with what? 1 plus x by under the root x square minus 1. So what happens to this? dy by dx equals to n into x plus under the root x square minus 1. This is n minus 1 into, take LCM, that becomes x square minus 1 plus x by under the root x square minus 1. So if you take LCM, x square plus 1 into LCM, this goes one time, 1 into this, this goes x under the root x square minus 1, x square minus 1 to this becomes x square minus 1 plus x square cancels, 1 into x will be x. So what do you find here? See in the numerator x plus under the root x square minus 1 into n minus 1, I will take this to the power 1. So here also we will rewrite this. I call this as equation 1 by rearranging equation 1, we get what happens here, dy by dx equals to n into x plus under the root x square minus 1 to the power of n minus 1, and this a plus, now it is b plus a, make it a plus b, so that I can rewrite this as what? So x plus under the root x square minus 1 divided by under the root x square minus 1. Can write like this. So this is x square minus 1, x square minus 1 plus x. What I have done? The same thing I have written x plus x square minus 1 by the. So why I have done this? We have here x plus under root x square minus 1. Here also x plus under the root x minus 1. So bases are same, add the indices. So I have taken this as to the power of 1. What happens to this? Dy by dx equals to what? N into x plus under the root x square minus 1 n minus 1 at its root. I write it here as, I write this as x square minus 1. So bases are same, add the indices plus 1. Can write like this. See here, x plus under the root x square minus 1, x plus under the root x minus 1. So both the bases are same, add the indices n minus 1 plus 1. So what happens here? I'll rub this. So dy by dx equals to what? N into x plus under the root x square minus 1 whole to the power of n by divided by 1 minus, x square minus 1. So here plus 1 minus 1 cancels, so we get to the power of n. Now what I will do is, this is your dy by dx is nothing but y1, but I want y2. So what I will do? I rub this. So can I write like this? dy by dx is nothing but y1, which is nothing but y1. This is n into, what is this? Can I write this as y divided by under the root x square minus 1. I call this as equation 2, since y equals x plus under the root x square minus 1 to the power n. So I substitute this entire value with y. So this is what? That is y1 equals to n into y. So this is our equation 2 divided by x square minus 1, isn't it? So what I'll do, I'll cross multiply this. That becomes what? X square minus 1 into y1 equals to n into y. I call this as equation 3. Now, dear students, to solve this or to differentiate this, I need to get rid of this square root. How to get rid of this square root? So, what I'll do, in order to differentiate, because we have got only y1 up till here, we have differentiated only once, isn't it? But we need y2. To get y2, again I have to differentiate equation 3 with respect to x. To do that, there is not a healthier way or easier way to differentiate. What I'll do is, to remove this root, I square both sides. If I square both sides, this root is off, it's gone. So what I'll do, I'll rub this by squaring equation 3 on both sides. We get, what happens? So if you square this, it becomes x square minus 1, and this becomes y1 square equals to n square y square. Done. So now we'll differentiate this. I call this as equation 4. Differentiating equation 4 with respect to x. What happens? Here use product rule. What I'll do is, I'll keep x square minus 1 into d by dx of y1 square plus y1 square into d by dx of x square minus 1 is equals to n square into d by dx of y square. So let's solve this. So what happens here? So this becomes, this is x square minus 1. If you differentiate this, this becomes 2y1 into y2, because differentiation of this will be 2y1 and differentiation of y1 will be y2 plus y1 square into d by dx will be 2x equals to n square, this will be 2y into y1, correct? I repeat, x square minus 1 as it is, so x to the power of n, that is nothing but 2 into y1, differentiation of y1, that becomes y2 plus y1 square, I kept as it is, d by dx of x square is 2x and this is constant 0, leave it off. So n square, this will be 2 into y, if you differentiate y it becomes y1. Clear? Am I clear? Yes? Okay. I rub this and solve. What happens here? X square minus 1 into 2y1 y2 plus y1 square, sorry, I'll write like this, 2 y1 square equals to n square into 2y1 into y. I have rearranged it. After having done so much, what I'll do is I'll divide throughout by 2y1 by dividing throughout by 2y1. What happens? We get, so here 2y1 cancels, that becomes x square minus 1, so we get y2, so here 2y1 we get plus 1y will go, so we will have 1y x equals to, so 2y1 will go, this will be n square y, right? What he wants? X square minus 1 into y2 x y1, but I have got y1 x, so we will rearrange it. He wants minus n square y. I will bring it to the left hand side over. So by rearranging, what happens here? X square minus 1 into y2 plus x y1 minus n square y equals to 0. What do you want? X square minus 1, x square minus 1 into y2, yes, we got it, plus x y1 minus n square y equals to 0. We got it? Hence proved. Dear students, these are all examination questions. So the earlier what I did also the examination question and this also. Either we will get m or n to the power or similar, so you can work. So if you want another two problems similar on the similar grounds, I will work. And if you need part 3, I definitely will go for it. If I find more important problems, I definitely I'll take I'll do part 3 of successive differentiation, and later on I'll move to partial differentiation, because I want to finish successive differentiation. I want to see that you're fully equipped to tackle any sort of problem given to you. So dear students, I want to prepare you for your exams, and I want to see that you get full on full, no compromise. So dear students, I have proved this. Let us see what best I can do. I'll select some more problems and do it. So stop here and go for the next problem. Dear students, we have a problem. If sin inverse y equals a into sin inverse x, prove that 1 minus x square into d square y by dx square equals to x into dy by dx minus a square y. So dear students, what happens here is, the moment you see this problem in the examination, some of you will not think how to solve this problem. You will feel we have choice, we will neglect this problem, we will go for the next problem. So even though this problem is very simple, very easy to do it, but what you do, because of some problem, some tricks here, you will avoid that problem, you will go to the next problem. Here the examiner wants to tease you, or to find, or to try how well you are equipped to solve such problems. So what you do, he will select such similar problems to you so that you get stuck and you leave it off. But the intention is not to see that you avoid it, but you people are not equipped. So that's what he wants to try, whether you are prepared or not for the examination. So you can anticipate such questions in the examinations. So this problem is very simple. You can easily solve this. The first step is very important. The moment you see the first step, definitely you say, sir, this problem is very easy. I don't know how I left this problem. So I am going to teach you that trick. So likewise, every problem will have some tricks. So I will teach you all the tricks, provided you follow my videos regularly and don't miss out on it, because you will have, because I select questions which are very important to you and which will play with your sentiments. This problem definitely will be, for some extent, in the event if you attempt this question and you don't solve it throughout the day, it will be haunting you. It used to happen with me as a student. In the event I try something, I try, because you will be wasting much of your time on thinking. So better keep these questions for the last in the event if you get such questions. So what you do is, so keep trying and do it. So I will see that you are better equipped and you will attend all problems. So what I do usually, I select some important questions which is filled with this sort of things which will benefit you. So don't miss out on my videos. So I will select questions to see that you are well equipped and you answer your questions very well in the examination. That is my motto. So dear student, without wasting any time further, let's start this problem. The moment I do the first step, you will definitely feel very happy. Sir, we know this problem. I am sure about it. Let's see. Now dear students, you have sin inverse y equals a into sin inverse x. Okay. A into sin inverse. What I will do is, given sin inverse y equals to a into sin inverse x. Shall I disclose the trick now? Yes? Yes. So what I will do is, such cases you transfer the sin inverse x, that is sin inverse, to the right hand side. What happens? This becomes y equals sin of a into sin inverse x. Now this has become a composite function, isn't it? Yeah, earlier you had inverse function on both sides. Now we have converted the inverse function into a composite function. This is the only trick, and later on you have more similar things. The story doesn't end here. You have a lot of tricks to follow. We'll do it. So, but most of them are similar to earlier problems, but you can do. Okay, dear students, what I'll do is, I'll differentiate this with respect to x. What happens here? We're differentiating this. So here, this is a composite function. Remember, students, once again I'll tell you, some student examination, instead of writing sin of a sin inverse x, what they do is they change it into product rule. They introduce one x here. They make it sin x into a into sin inverse x. Please don't do that. It is a composite function, and I taught you composite functions in my earlier videos. So let's solve this. So by differentiating, I call this as, okay, no need, by differentiating equation 1, okay, equation 1 with respect to x. What happens? That is, dy by dx equals to d by dx of sine of a sine x, right? So now we'll differentiate this. What happens if you differentiate sine of a sine inverse x? Sine becomes cos and d by dx of inner function, right? So what happens here? This equals to what? dy by dx becomes what? Cos of a sine inverse x into d by dx of a into sine inverse x. I'll rub this. dy by dx equals to cos of a sine inverse x a into this becomes 1 by under the root 1 minus x square. You know that d by dx of sine inverse x equals to 1 by under the root 1 minus x square. So I use a formula for this. Okay, I rub this. That is nothing but dy by dx equals to a into, I take this a here, this becomes cos of a sine inverse x divided by, this is under the root 1 minus x square. So dear students, please remember here one thing. Whenever we get dy by dx of an inverse function, that is sine inverse or cos inverse or tan inverse, whatever it is. So you are, in this case, sine inverse, what you have got? 1 by under the root 1 minus x square. Again, don't write it d by dx of minus 2x. You do that, you've gone wrong. This is a formula for sine inverse x. Don't try to modify this. When you're doing a problem, d by dx of 1 by this. For example, you're doing d by dx of 1 by 1 under the root 1 minus x square. That time you get minus 2x. That is x square minus x square. D by dx, you have to differentiate this. First you are going to differentiate this, later on you are going to differentiate this. That is in the case of when you have this. But here in the formula, don't try to take here minus 2x, that is minus x square. You will go wrong. So only this much. I'll rub this. Now what I'll do is, I'll try to cross multiply. So if I write this as a cross multiply sign, that is dy by dx into under the root 1 minus x square equals to a into cos of a sin inverse x, isn't it? See, this portion will go here, right? So I left with what? Only a into cos a into sin inverse x, and this root has gone to the left hand side by cross multiplying. So I call this as equation 2, and I rub this. So इसके बाद क्या सर क्या करेंगे? इस रूट को हटाना है, तो इस रूट को हटाने के लिए क्या करोगे? इसे स्क्वायर करो. If you square this, you have to get rid of this root, because we want 1 minus x square. To get 1 minus x square, what we have to do? We have to square both sides. If you square, automatically this root will vanish. Okay. So what I'll do next? Squaring equation 2 on both sides. What happens? I love this too. If I do this, what happens here? Here, that is into, that is dy by dx into under the root 1 minus x square equals to a into cos of a sin inverse x. I call this equation 2. Now I have to square both sides. Is it there? Yeah. What happens here? So here, dear students, if you have dy by dx, if you have to square means how do you square? Is it correct? No, this is wrong. So dy by dx, if you have to square both sides means it becomes what? Dy by dx the whole square. So if you are asked to square dy by dx, means it means this is not the case. I have seen most of the students in the examination, the moment they are asked to square both sides, they do this. The moment you do this, you are gone. The examiner will not go ahead with the correction. Straight away he will put one big under 0 and he will stop at that. So dear students, be careful here. Dy by d the whole square, you are squaring now both sides means this becomes dy by dx the whole square, that is dy by dx the whole square, and this becomes 1 minus x square. I told you that is root x the whole square is nothing but root x into root x, which is nothing but x. So here this root x, this becomes what? 1 minus x square into 1 minus x square is nothing but 1 minus x square. So that's what has happened here. So root vanishes off by squaring, because I have to square that in order to get rid of that square, and I want this 1 minus x square. How will I get 1 minus x square? Only if you square both sides will this root vanishes. So in order to see that the root is cleared off, we are going to square both sides. So this is dy by dx the whole square into 1 minus x square. This is important step. This is a square. Don't write like this. This is cos of a sin inverse x. Don't write this. If you write this, it's gone wrong. You have to take 2 into cos of this and later on differentiate in a function also. That's not the case. So what happens here? This one a into, this becomes cos square of a into, a into sin inverse x. So squaring, if you have squared both sides, this becomes cos square of a into sin inverse x. Remember this step, very important step. This step is very important. So most of you go wrong here also by writing that. That is to whole to the power square. Don't do that, write this. I'll rub this. That which implies, that is dy by dx the whole square into 1 minus x square equals to what? Equals to a square. What I will do here, we know this. What is this? Sin square x plus cos square x equals to 1, or cos square x equals what? 1 minus sin square x. I use this concept here. I will remove this and write 1 minus, I will use if lower bracket 1 minus sine square of A sin inverse x. So what I have done, instead of cos square I have taken 1 minus sine square of A into sin inverse x. So that is equals to dy by dx the whole square into 1 minus x square equals to minus y square. 1 minus y square. See here we have 1 minus sine square of A minus sin inverse x. So that becomes 1, because what is we are given here, note sin inverse y equals to A into sin inverse x, or y equals to what, sin of A sin inverse x. So we have square here, so that becomes one y square. So here I have written A square into the entire portion becomes 1 minus y square, and this is our equation number 2 or 3, I don't know. Anyway, I write 3 to be safer side. So now once you have come to this step, you can differentiate again. By differentiating again you will get this. So let's differentiate. I love this. What happens? Here we have two functions, that is dy by dx the whole square into 1 minus x square, and we have here. So what we are going to do? We are going to differentiate both sides with respect to x, and here we have to use product rule, because function of it has a y is a two functions. We have two functions here, so using product rule. So how to go about it? I will rub this also. Differentiating equation 3 with respect to x. What happens here? So use product rule here. So what I will do is, first dy by dx the whole square into d by dx of 1 minus x square plus 1 minus x square into d by, I will take this, okay, into d by dx of dy by dx the whole square equals to, I take this a square outside, a square into d by dx of 1 minus y square. I love this. What happens here? So if you differentiate this, this is our written, that is dy by dx the whole square. If you differentiate this, what happens? You get minus 2x, because dy by dx of 1 is 0 minus sign x square becomes 2x plus 1 minus x square. And here is an important issue. Be careful here, most of you go wrong here. See here, dy by dx the whole square is not equals to d square y by dx square. Remember this. Most of the students, they commit this mistake in examination. You're not supposed to do that, because I'll show you. So you have written as it is. This becomes what? Into 2 into dy by dx, and dy by dx of this will become d square y by dx square. So we are going to differentiate the inner function. Here this is of what? D by dx of x to the power of n, that is nothing but n into x to the power of n minus 1, and d by dx of x. What happens? D by dx of x is 1, so that is ignored. So that becomes finally n into x to the power of n minus 1 into 1. So here also same case. So but here what happens? 2 into, that is n into dy by dx into differentiation of dy by dx becomes d square y by dx square. So I'll rub this. So this becomes what? A square d by dx of 1 is 0, and this becomes minus 2y into y1. Remember this here. We are going to differentiate this x to the power of n type. So 2 into y, and differentiation of y is y1. Done. So what happens here? We'll differentiate this. That is what I'll do is, this minus sign to begin with is not nice. I write from beginning, I hate the minus into it. I rearrange it. By rearranging, I call this as equation 4. By rearranging, equation 4, we get what happens. I'll write first this one and later on I'll write there. So what happens here? I'll rub it. So first, that is 1 minus x square into 2 d square y by dx square into dy by dx into dy by dx minus 2 into x, and this is dy by dx whole square equals to minus a square 2y y1. Instead of y1, I'll write this as dy by dx, because y1 is nothing but dy by dx. I have written dy because everywhere we have dy by dx. So I have written this as dy by dx. So what is y1? y1 is nothing but dy by dx. y2 is nothing but d square y by dx square, and so on. I taught you this in the previous class when I was doing implicit or whatever implicit or parametric functions. I have taught you this. So what about this? So dear students, we'll use, instead of y1, I have put dy by dx. What I'll do, I'll divide this equation throughout by 2 dy by dx. Divide equation 4. This was nothing but equation 4. Equation 4 throughout by 2 into dy by dx. What happens? So here one minus x square. If you divide 2 by dy by dx, this and this cancels. You are left with what? D square y by dx square minus 2 is gone, 1 dy by dx is gone out of this. So this becomes x into dy by dx equals to 2. Here 2 also is gone. So I left with a square. See, this 2 and this dy is gone. So you are left with minus. You are left with minus a square y. See, this 2 and 2, if you divide this by what happens? That is 2 dy by dx. This and this cancels, 2 and 2 cancels. We are left with a square y. Done. So dear students, we are left with what? Now what he wants? He wants 1 minus x square into d square by dx. So 1 minus x square into d square by dx square equals to x plus dy by dx. That is x, if I send it here, it becomes plus x dy by dx minus a square by minus a square. So we got it. So by rearranging equation 5, I call this as equation 5. What happens? That is 1 minus x square into d square y by dx square equals to that is 1 minus x square into d square y by dx square equals to, I sent it there, it become plus x into dy by dx square minus a square y. So hence proved. So dear students, do you think this problem is filled with lot of interest, tricks, and it motivates you to go for next problem? Yes, we'll go for next problem. So dear students, try to understand this and try to do this problem once again, because in first attempt you cannot succeed. So you have to keep your scribbling pad, try to practice it, because sometimes even we go wrong because we'll be preoccupied with certain things, so we go wrong. So dear students, please see that you don't do that, because you're still a student, you don't have domestic problems of any financial problems, because your parents are behind you to support you. Done? So we don't have anybody to support me. So we have to do, that is our self-help. So dear students, let's stop at this and go for the next problem. So dear students, we have a problem. If y equals e to the power of m sin inverse x, prove that 1 minus x square into y2 minus xy1 equals to m square y. So dear students, most of the problems are very similar to each other, and here you will get variety of problems, but the solution is same, but certain problems involve some secrets which you have to do but this is a simple problem. But in the event if you get this sort of this sort of problems in examination, I don't want you to leave it and come back. So I want you to complete the problem and come, because when a soldier goes to a war, he'll take his gun, his weapons with him, finally shoot the opponent and come back. So when you go to your exams, get prepared and finish your problems and try to score full on full. Don't try to neglect or leave any problems because you don't know one small trick. So let's solve this problem. So let's differentiate this with respect to x. What happens? Given y equals e to the power of m into sin inverse x. So differentiating with respect to x, what happens? Dy by dx equals to d by dx of e to the power of m into sin inverse x. So we know e to the power of ax is e to the power of ax into a, that is d by dx of e to the power of ax is nothing but you write e to the power of ax as it is and you take the differentiation of ax, that is ex to the power of ax into a. If it is b, take b, whatever it is. In this case we have m. This. So what happens to this? What happens if we differentiate this? Dy by dx equals to what? E to the power of m into sin inverse x into d by dx of, I'll write that also, into d by dx of m sin inverse x, because some students are there, they may not. So you have to differentiate this also. What happens? This becomes e to the power of m into sin inverse x into m into d by dx of sin inverse x is 1 by under the root 1 minus x square. Done. So what I'll do? I'll write this dy by dx equals to, I'll take this m in the beginning, that is m into e to the power of m into sin inverse x divided by under the root 1 minus x square. Can I write like this? Yes. That is dy by, okay, I'll stop there, I'll avoid one step. So what I'll do here, I'll cross multiply. What happens? This will go there, that is dy by dx into under the root 1 minus x square under the root 1 minus x square equals to m into, what is this? That is nothing but our y. So this becomes our y. So after this what will I do? I had told you he wants 1 minus x square. In the event you want to get 1 minus x square, what will you do? I had taught you in the earlier problem. So square both sides. That is the only way out. If you square both sides, you will get rid of, you can get rid of under the root 1 minus x square. So you can get rid of the root. So I call this as equation, I don't know whether it is equation 1 or 2, yeah, equation 1, squaring equation 1 on both sides. What happens? We get, that is dy by dx the whole square, and this becomes 1 minus x square, and what happens to this? This becomes m square into y square. I call this equation 2. Okay, I'll rub this. I'll rub this to. What I'll do, I'll differentiate equation 2 once again. Now, differentiating equation 2 with respect to x, we get what? I'll rub this to. What happens? So here we have to use product rule because we have two functions here. We have to use product rule. So that is, I keep first function as it is, that is dy by dx. I'm going to square both sides. So, differentiating it. What happens here? So first function product rule. So here we have two functions, use product rule. So first I'll keep this dy by dx, the whole square as it is, d by dx of 1 minus x square plus 1 minus x square into d by dx of dy by dx the whole square equals to m. I'll take the m square outside. This is d by dx of y square. I rub this. I rub this too. No need now. So what happens here? I'll keep this dy by dx the whole square into, this becomes d by dx of 1 is 0 and this is x square is 2x plus 1 minus x square, and d by dx I had taught you in the thing, that is into 2 into dy by dx, and differentiation of dy by dx, it becomes d square y by dx square equals to m square. Here this becomes 2y into y1. So here we have dy by dx, and here we have in terms of y1. So either you change throughout by y1 or dy by dx retained. So what I do is, he wants everything in terms of x2, y2, y1 and y. So I'll change this. So what happens is, dy by dx is nothing but what? y1 square minus 2x plus 1 minus x square to y1 and y2, this is y1 and this is y2, equals to 2 m square y into y1. I don't want this minus sign here, I'll rearrange it. I call this as equation 3. By rearranging equation 3, we get what? First I use this 1 minus x square into 2 y2 y1 minus 2x y1 equals to 2 m square y into y1. What do you want? He wants 1 minus x square into y2. So 1 minus x square is there, but we want y1 and 2 is there. So what I will do is I will divide throughout by 2y1. What happens? Look at this. By dividing throughout by 2y1, I call this as equation 4. By dividing, I write this equation 4 throughout by 2y1. What happens? So that is 1 minus x square 2y1. So 2y1 divided means we get y2, 2y1 goes. So here 2y1. So we'll have these are 2y1 square, sorry, these are 2y1 square. So what happens by dividing that? So this becomes x y1. While writing, I am actually by oversight I made it 2x into y1 because we had d, that is, so this is 2 and 1 y will go, we will have, that is 2x y1 square, that is nothing but 2x into y1 into y1. So 1 y1 divided by 2 y1. So 1 y1 and this cancel, left with x y1 equals to, what happens here? 2 and y will go, y1 will go. So we left with what? M square into y. So what happened here? What he wants? 1 minus x square into y2 minus x y1 equals to m square y. We got it. 1 minus x square y2 minus x y1 equals to m square y2. Hence proved. So dear students, so let us stop at this, because if I start doing more problems, the video will become very long and it will be boring for you. So this is more than enough for you. So if required, I will just see some more question papers. If you have another problems to cover, some important problems to cover, I will take up in part 3. Otherwise, we will end up for part 2 itself, provided you assure me that you are going to work some more problems in the textbooks. So because successive differentiation is very important for you to be successful. So that's the reason I have taken a lot of time to see that you have a lot of variety of problems, a good variety of problems, and I have given you that varieties. So take care of this and try to solve most of the problems one by one, and try to be well equipped, because without being well equipped you cannot face the exams. So I am preparing you and you get prepared to tackle any problems in the examination. So dear students, we will stop here and try to start. In the event if you require one more class number part 3, I will do it. Otherwise, if not prepared, straight away I will go to partial differentiations. Okay, that is also a very interesting chapter. We will go for partial differentiation in the next class. So be regular, don't try to cut off the class. This is my video number 28. So I am going to post one more problem, a very important problem for the examination, that is video number 29. consecutively. So after this you will have one more video 28 and 29 simultaneously. I am going to post it today. So try to solve that, because that's a challenge for you whether you can solve that problem. If you can solve that problem, it is worth having learned this differentiation from me. So follow my video number 29, that's class number 29. After going through this, or both are same, you are getting prepared. So dear students, I need not tell you to share, like and share my videos, or subscribe to my videos, to my channel, because I deserve for my hard work. I deserve your subscription for my hard work, and you are going to subscribe to me. So it's only an advice, only a request. I hope you'll do that. So dear students, let us stop here with a note. We are going to start partial differentiation in my next class. So before that, please share, like and subscribe to my channel, which is very important. So because I really deserve for my hard work. So dear students, all the best. Take care of yourself. God bless you. And before I conclude, please revise all my videos and try to solve all the problems, and try to share it to your friends, relatives, your classmates, your colleagues, and let it help everybody. So good night dear students. God bless you. Take care. Bye.